Okay, welcome everybody. Thanks for coming. This is the week 8 webinar of the class. So let me tell you the plan. As always, I'm always happy to answer any questions you might have. You can post in the chat. You can also ask if you want, but I'm definitely going to be, always helping you out. And then after that, last week we talked about hypothesis testing. So that was the week 7. And we did, a bunch of examples. This week we're going to do some really the most important ones. Hypothesis testing more often is used to compare things, to say which is better, or, hey, was this year more than last year? Or, when you don't know the population mean of either or the proportion. So that's what we're going to be doing this time, and also confidence intervals. So not just hypothesis testing, but confidence intervals. So pretty much everything that we did the last 2 weeks is coming back. So hopefully you got that stuff down, because that's really needed for what we're doing this week. And if you do have that down, this week's not that bad. So we'll start out for a hypothesis test and confidence intervals for the difference between two proportions. Then after that, we're going to get a hypothesis test and confidence intervals for the difference between two means when the means are when the data are independent of each other. So I'll explain more on what that means little when we get to it. And then we'll also get into a hypothesis test and confidence intervals for the difference of two means when the data are dependent. So again, the three main types, and they come up a lot, all three of them. So it's very important that we get this down. It's so important that what we're going to be doing today is project 2. So what we're covering today is what project 2 is going to be all about. So I will talk about the project 2 requirements and the details. Last time I kind of briefly mentioned it, but now we can get into the details, because by the end of this webinar, we'll fully understand hypothesis testing and confidence intervals for a difference between means. And that's what it's going to be about. Just want to remind you, this is week 8. 8 is an even number. Why is that important for this class? Yeah, so there's a week 8 exam because it's an even number. So don't forget, I recommend by Saturday, no reason to wait until the last day, because that's when things can go bad with the internet or whatever. So, get that done this week, because every exam is worth exactly the same amount, or same percentage of the grade, which is 10% of the grade. So each one's important. So it's really important to get that one down. So any questions about anything before I get started? Okay, if there's no questions, one thing, and I've mentioned this multiple times, but I'm going to mention again, what I love about this class is that it's so useful. And pretty much every week I can find something that it relates to what's going on now. So see if you know. Hopefully you do. I really hope you all know. What is the big thing that happens, or happened actually already, most of it, today in California? Yeah, the election happened. Okay. And this is in my entire voting time, my lifetime of voting. Um, there was only one thing on the election this time. Hopefully you all voted, that if you're registered or eligible to vote, hopefully you all voted. I passed my vote. What I don't do is tell you who to vote for or what to vote for, because that's not my job. But I do recommend you voting. That's important for those who can vote. Um, so in particular, there was only one item on the ballot. What was the item for California? And in your town, there could have been more. In Tahoe, there was only one. Yeah, Prop 50. So I figured, let's do Prop 50 a bit. So I have a question. And the question is, are Democrats more likely to vote yes on Prop 50 than Republicans are to vote no? Okay, what do you think? What do you think? Do you think Democrats are more likely to vote yes than Republicans are to vote no? That's a typical thing you can guess. And again, at this point, we can't know the population of all voters. Um, we can we can know about the election tomorrow, maybe, but not right now. Um, so what's your guess? Okay, so maybe no. Okay, but we're going to use a 5% level of significance, and we're going to compute and interpret the 95% confidence interval. So notice this is like last week and the week before, but the big difference is here we have two populations. We have the population of California Democrats, and we have the population of California Republicans. Okay. And just to let you know from the survey that we're going to be looking at, what we really care about is those who have already voted or likely to have voted. Okay, that's really what matters if you're going to conduct a survey. If someone's not going to vote, then who cares? Because that's not going to help you on what's going on. Okay, so again, it's really the scientific method. Do you remember the first step in hypothesis testing? Because that's what the first question is we want a 5% level of significance. What's the very first step on hypothesis testing? And it has to be step by step, and it needs to be in order. Do you remember? That was all last week, and it hasn't changed. Who remembers the first step for hypothesis testing? You had to do it multiple times last week. Yeah, you have to state the null hypothesis, and I'm going to put these together and the alternative hypothesis because you really interested in both at once. So let's do that. Okay, the difference between this week and last week we would have the first thing, the survey question is, are you going to vote yes on Proposition 50? That's what you're going to ask Democrats. And the survey question, Republicans, are you going to vote no? And the person is going to say yes or no. Does that make sense? Okay, so because of that, we have proportions, but now we don't know about either population. So we're comparing two populations. So H naught colon. Now we're going to have the proportion of Democrats, and I'm right, PD for the ones that are voting yes, and the proportion equals the proportion of Republicans who are voting no. Any questions on that? And H1, what's the key word here that I was able to decide that it was a greater than? Or key two words? What's the key word in this question here that tells us what inequality to use? Because it's always going to be greater than, less than, or not equal to. So what's the key word? Yeah, more likely. Okay, more means the proportion for Democrats is greater than, because more means greater than. Is that clear to everybody? So that's how I came up with this greater than. And then greater than the proportion of the Republicans. And I like to use sub D and sub R for this kind of thing because then you really understand what you're talking about. If you use P1 and P2 every time, it's really confusing. So I like to, if I can, if there is a good letter to use, I use a letter. Any questions at all on this hypothesis? Okay. So the next step, which I didn't do, but it was done, is Who remembers the next step after you state the null and alternative hypothesis? And by the way, we're given that we're going to be using a 5% level significance. So we don't have to decide on level significance because we're told. This was for news, and news uses 5%. That's standard. What's the next step? Yeah, you would normally state the ramifications of type 1 and type 2 error, but that's to find the level of significance. But here we're told what it's going to be. It's 5%. Okay. And by the way, ramifications of a type 1 error is, you know, yeah, so that would be, you're publishing in the paper or something and it was wrong. And then everyone's going to laugh at you how stupid you are, right? Okay. Whereas the ramifications of a type 2 error is you don't publish, but you were actually right in the first place and you would have had a good article to publish. And that'd be pretty bad because then one thing is that, if you're in charge of this, news station or whatever, then you don't have anything good to talk about. And that's not good either. That's going to hurt your station. They both hurt. Okay. But we're told to use a 5%. What happens after deciding on level significance? It's very step by step. It's the hardest part of hypothesis testing in the real world by far. It's over 100 times harder than everything else combined. So what's the next step? No, we're not ready to state whether it's true or not. That's not the next step. The next step is to collect your data, right? Before you collect your data, you have no idea whether it's true or not. Does that make sense? That's the hardest part. Okay. And in this case, it was a Berkeley IGS poll. I always like to cite my resources. This is real. And what they asked, ND means the number of Democrats that were surveyed, and there were 2,216. And that those are going to be Democrats who are likely voters. Okay. And I will let you know I'm not going to get into I'm not going into the details of this, but they use stratified sampling. Okay. I read the whole article, but we can't go into everything, but hopefully you know that from what that means from the first chapter or two. And then NSABAR, the number of Republicans they surveyed were 1,257. Okay, which makes sense actually because California has a lot more Democrats than the Republicans. Okay. And what they found is amongst the Democrats that they surveyed, 93% of them said that they were going to vote yes on Prop 50. And for the Republicans they surveyed, 91% said they were going to vote no on Prop 50. Okay. So now, once you've gotten the data, what do you do next? What's the next step? Very important. Who remembers the step after collecting your data? And collecting the data would be a huge amount of work. Surveying thousands of people would take many, 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 many days. Okay. Unless you had a huge team. But what's the next step after you collect your data? And the order of the steps are important. Just to let you know, project two, you're going to have to do this, and you better have the steps in order. So what's the next step? Let's see, I'll pop in the chat box. Okay, let me remind you. Let's use a calculator. Do you remember that? We need to find the p-value. So now, what calculator do you think I'm going to use? Okay, and yes, you are required to use this calculator for everything but the projects. Which one do we use? Yeah, number 20. We have two proportions. Okay, there's going to be a hypothesis test and a confidence interval for two proportions. So I'm going to click on that. And we have to put in the sample sizes and the number of successes. We're going to have to put the tail type, the confidence level, and then pooled or not pooled. I'll explain that in a little bit. But so the sample sizes again, now we just got to remember 2216 and 1257. So 2216 and 1257. The number of successes, that's a little more detailed. Well, 93% of the Democrats said yes. Okay, yes, they're going to vote yes on Prop 50. How do we get the number of yes successes if we know 93% said yes? Do you remember the math to do? Here's a hint, we're going to need a calculator. Nothing too intense, but we got to know what to do. How do you get the number of yeses or the number of successes? Let's see, y'all jumping in. Well, if they surveyed 2,216 people, and if 93% of them said yes, then we're going to take 2,216 and then we multiply by 93% is 0.93. And you always round to the nearest whole number, by the way, because you can't have 2,060.88 people say yes. So it's 2,061. Okay, for the second, it was 1257. And if you remember, 91% of the Republicans said yes, they're going to vote no on 50. Okay, that's why I sometimes call it number of successes. So 0.91. So times 0.91. And again, round to the nearest whole number would be 1,144. All right. Notice that in our H1, we have a greater than. So we're going to click on greater than. Notice also, we are asked for a 95% confidence interval. So under CL, we're going to go 0.95. Any questions so far? Okay, so the question is, wouldn't it be 7% for the other side or something like that? So the key is the question. Are Democrats more likely to vote yes than Republicans are to vote no? Do you see? So we're going to call it a success for the Democrats if they vote yes, or say they're voting yes. We're going to call a success for the Republicans if they say they're voting no, because that's what the survey, that's what this sentence says. Does that make sense? Yeah, so that's the answer to that. Good question, though. Real good question. That's why, in particular, when I coded this, I didn't write number of yeses. I wrote number of successes because then it can be confused. All right, just to let you know, if the question that you're doing on the assignments, for example, or the exams say pooled, then you got to click pooled. If they say not pooled, click not pooled. The default is not pooled, so I'm going to keep it on not pooled. It's a little complicated and my feeling is elementary stats, we don't need to talk about pooled versus not pooled. But some other people wanted me to code this in from other universities or colleges. So then I just say calculate. And here we have everything we need. By the way, the z-score is a little bigger than 2, 2.059291. That's the z-value. That's the test statistic, I should say. The p-value is about 0.02. We have a lower bound. That's the lower bound for the confidence interval is about 0.0009. And the upper bound for the confidence interval is about 0.039. Okay, rounded to, enough decimals. And pictures are often shown. Any questions at all on using this calculator? Hopefully you're seeing this is a lot like last week and the week before. So now, again, the p-value was about 0.02. Okay, definitely 2 decimals is enough because I'm comparing with a 5% level of significance. So do you remember if the p-value is 0.02 and we're using a 5% level of significance, what does that tell us? Again, same thing happened last week, but now we just have two surveys instead of one, or two groups, two populations instead of one population. But what does it tell you if the p-value is 0.02? The level of significance is 5%. What's the big conclusion? You remember? Okay, so one thing is 0.02 is less than 0.05. That's 5%. Does that ring a bell? And if p is less, that means you get to reject H1. I mean H naught. You get to reject H naught and accept H1. And it's time to state the conclusion. And it's really the same idea that we did last week. The first 5 words are exactly the same. There is statistically significant evidence, and even the next one, to conclude that. Okay? So remember that when the p-value is small, then we have statistically significant evidence. If the p-value had been large, then we would have statistically insignificant evidence. Is that clear? Yep, same words at the beginning. Obviously, things can be a little different, and they're always a little bit different because here we're talking about Prop 50 and Republicans and Democrats. So, every example is going to be a little different. Don't just write down only the template. Make sure you write about what's going on. So conclude that. And now here's really important because we have a proportion, a yes/no survey question. It's the population proportion. Do you see that? And those words are required. So you're hearing it in the webinar. You have to have these words. If you're talking about proportions, you better have the word proportion. And you better refer to the population. So the population proportion, and now it's about Democrats voting yes on 50. So population proportion of Democrats who will vote yes on Prop 50 is larger than, because of this greater than in H1, is larger than the population proportion of Republicans who will vote, oh, that should be no, on 50. Any questions? Any questions on that? By the way, based on this it's not quite off topic, but it's definitely something. Will 50 pass? And by the way, you can't know exactly from this, but if you know about California, you should know. Will Prop 50 pass? If this study was done right? Is it likely? based on this? Is it very likely it's going to pass? The answer is yes, because one thing that you may or may not know about California, but you probably know, is that there's a lot more Democrats than Republicans. So if the population proportion of Democrats are going to vote yes is larger than the population proportion of Republicans are going to vote no, then there's definitely going to be more yeses because there's a lot more Democrats than Republicans in California. Okay, that's assuming, most people vote. Okay, so this one's probably gonna pass, but we won't know yet, probably till tomorrow or maybe a few days. Okay, any questions on the conclusion? Okay, so one thing, again, this is just like last week. Um, I'm just fixing a few things. It's just like last week. Not only do you want to state the conclusion, it's really important you know how to interpret the p-value. The p-value is as follows. If the population proportion of Democrats who will vote yes on 50 is the same as the population proportion of Republicans who will vote no on 50, and if we surveyed another 2,216 Democrats and 1,257 Republicans, then there'd be a 2% chance, that's our p-value, p was 0.02. So there'd be a 2% chance that the new study would have the same sample proportion of Democrats who will vote yes on Prop 50 at least 2% higher than the sample proportion of Republicans who will vote no on 50. By the way, it's a little confusing and sorry about this, but that's what real world stuff happens. These 2% come from different things. This 2% comes from the p-value. This 2% higher comes from that 93% is 2% higher than 91%. Okay, it's one of these confusing random coincidences. Those are going to be usually different. But in this case, they're the same. And I wanted to do something that was the relevant thing today. And comparing Democrats and Republicans makes a lot of sense. Any questions on this example? Okay, let's do another example. Let's interpret the level of significance now. And it's very similar. Let me fix a few things. So if you remember, if you looked at the interpretation of the p-value and you look at the beginning all the way up to there would be a, that will be exactly the same as the interpretation of the level of significance up to there would be a. So if the population proportion of Democrats who will vote yes on Prop 50 is the same as the population proportion of Republicans who will vote no on Prop 50, and if we surveyed another 2,116 Democrats and 1,257 Republicans, then there would be a, and now level of significance is 5%. So 5% chance that we would end up falsely concluding that the population proportion of Democrats who vote yes on Prop 50 is larger than the population proportion of Republicans who will vote no on Prop 50. Any questions? Any questions on interpreting the p-value or the level of significance? Notice a lot of people make mistakes on this with level of significance. With the p-value, it's a chance that a sample would do something. With everything else, it's all about the population. Any questions? Okay, let's look at the confidence interval. Again, the confidence interval went from 0.0009 to about 0.039. So there's our confidence interval. And let's interpret it. Hopefully you remember, I know it's been a couple weeks, but the first word of an interpretation of the confidence interval is with. Okay, and you have to have that word. Okay, nothing's changed. So with 95% confidence, the percent of all Democrats who will vote yes on Prop 50 is between 0.09%, because I move this decimal 2, it's 0.09. And 3.9%, because that's if you move it over 2. And these are both positive numbers, so they're both higher for Democrats. Then the percent of Republicans, little mistake here, who will vote no on Prop 50. Do you not see the screen? Other people? Because it says on screen sharing. Okay, so everyone else can see it. So you might want to try, I don't know, closing your computer and turning it back on or something, but everyone else can see it. So that I'm not, it's really hard for me to know what's happening when only one person is having an issue. Sorry about that. But everyone else can see the screen. Yeah, it does say on my computer, you are screen sharing. Any questions at all on the interpretation of the confidence interval? Okay, you could also interpret the confidence level. I think I'm just going to say it quickly because it's the same idea is that if you conducted this survey many times, surveying 2,216 Democrats and 1,257 Republicans who are likely to vote, then you would say then each one would produce its own confidence interval. And 95% of those confidence intervals will contain the true population difference in proportions, or true difference in population proportions between the percent of all Democrats who will vote yes on 50 and all Republicans who will vote no on 50. So it's very similar to what we did 2 weeks ago. So it's the same idea. And we only have so much time, so I want to make sure that I don't spend all the time on one example and you don't see other examples. So we have a couple more examples and I want to show you the project too. So we do have a lot to do today. Any questions on the confidence interval idea? Okay, so let's do another example. This one's going to be a bit different. So here's the question. Do single women spend more time cooking than single men? What do you think? Do you think they do? Okay, so the idea is until you conduct a survey, you really don't know. Then you're just like guessing. So what you really do is conduct a survey. And I'm going to tell you this and that for this example, I made the numbers up. But you can imagine doing this. And and in fact, you could do, for example, you could do this for your project. Doesn't mean you should, but so the 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. The 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 16 minutes. What can be concluded at the 5% level of significance? Also interpret the confidence interval. Any questions on the question? Okay, I'm going to ask you a question. I want you to put in the chat box. That is, in the last 24 hours, how many minutes did you spend cooking? Put in the chat box.
Mira, click on the video Yusuf sent me. He wants you to see it.
Okay, good. Notice that when I'm looking at your answers in the chat box, they're all numbers, right? So this is not about proportions. Do not use P for this particular one. Instead of P, what do you think we're going to use for H naught and H1? when your answers are numbers like 120 or 90 or 30 or whatever it might be. So what are we going to use now instead of P when we stay H naught and H1? Do you remember? If we have quantitative data, and that's what we've got here. It's not Z. Definitely not Z, actually. And in fact, if you looked at the one we just did, that had the Z for the statistic. We're not going to have a Z for the stats. So it's definitely not Z. Do you remember? Here's a hint. It's a Greek letter. Not alpha. Alpha was for level of significance. This is for H naught and H1. What Greek letter? Different Greek letter. Here's a hint. When she was alive, my cat really knew this letter. Yeah, mu. Mu. Okay. So here is H naught. H naught colon, and I'm going to write mu sub W. So this is going to be the population mean number of minutes that women spend cooking is equal to mu sub N, which is a population mean number of minutes that men spend cooking. And notice we don't know the population of either. We just have samples for both of them. So that's why we're comparing mu W and mu M instead of say mu W as a number. It's not. It's we have two things we don't know. And H1 is mu W is greater than mu M because of the word more. Always look for those keywords. Any questions? Any questions on the null and alternative hypotheses? Okay. I want to mention something that's really important that we haven't talked about yet, so I need to tell you this is important. We looked at just a bunch of single men and a bunch of single women. The first man really has nothing to do with the first woman. The second man has nothing, they're not partners, anything like that. These are just a bunch of men and a bunch of women. So they're independent of each other. Okay. Had we looked at, say, brothers and sisters, then that would be dependent. And that's really important to note that. But this is just men and women in general. Does that make sense? So because of that, let's go to our calculator. And this calculator won't work because this is for two proportions and we're not talking about proportions. So I can go back to the calculator menu. And which calculator do we use? What number? Yeah, this is number 19. It's number 19 because we have statistics, we don't have data. Does that make sense? We have statistics. We're given the sample mean and we're given the sample standard deviation. We're not given the data. So it's two, and they're both independent statistics, samples with statistics. Okay, very important to use the right calculator or the whole thing falls apart. So our sample sizes were 35 women and 38 men. So 35, 38. The sample means were 58 for the women and 46 for the men. 58, 46. And the sample standard deviations were 12 for the men, for the women, and 16 for the men. RH naught, or sorry, H1 is mu sub W is greater than mu sub N. So I'm going to click on greater than. We want a 95% confidence interval. So our CL, confidence level, is 0.95. Any questions on getting this into the calculator? And I hit calculate. And there we go. We have a test statistic. Notice it's not Z, it's T, because now we're talking about proportions. We're talking about means and we don't know the population standard deviations. So we're doing a little extra um, guesswork. And that means we got to use T instead of C. The the test statistic is T is about 3.64287. The P value is 0.00026, very small. And then we could write our conclusion. So there is statistically significant evidence because, in fact, you could even say strong. We didn't have strong last time because we were 0.02, which is not less than 0.01, but this time we have strong statistically significant evidence to conclude the population mean cooking time for women is larger than the population mean cooking time for men. Any questions on the conclusion? Any questions? Okay. We can look at the confidence interval. And by the way, the confidence interval was, you can see, 5.4 for the lower bound, 18.6 or so for the upper bound. So again, the first word should always be with when you interpret the confidence interval. So with 95% confidence, the population mean time single women spend cooking is between 5.4 minutes and 18.6 minutes longer than the population mean time single men spend cooking. Are there any questions on the conclusion of the hypothesis test and the how to interpret the confidence interval? So just let you know that the hypothesis test is all about deciding whether it is true that women spend longer. The confidence interval is not deciding whether it's true. The confidence interval is how much longer. Do you see the difference? Okay, so they tell you different stuff. Confidence intervals are how much more or how much less. And hypothesis tests are, does it happen? Any questions at all on this example? Okay. Let me give you another example. This is the one where honestly, I make a lot of money on. Any guess on where I make a lot of money in statistics? I make a little bit teaching, by the way. I make pretty much. Any guess on where else I can make a lot of money, but using statistics instead of teaching statistics? Any thoughts? Okay, and I really do, by the way. Not always, but often. Nobody wants to guess? Okay, so let me tell you the stock market. Okay, so I have learned what I do is I look and I conduct hypothesis tests and look at confidence intervals. for stock market trends. And when I find something, especially that other people haven't found yet, then I know how to invest. Okay. Does not mean I make money every day. In fact, I lost $6,000 today. That happens, but a few days ago I gained 6,000. That happens up and down, up and down. But there are some times when I can be pretty confident that I'm going to make a lot of money. Okay. So I don't know if any of you invest in the market, in stock. Maybe not. Okay, let me give you an example where I did really well because I found something that other people for some reason didn't find. And that was, and by the way, I'm not going to say whether I like a president or don't like a president, but this was Trump's first presidency. So this was a while back. But again, it's not really easy to find patterns that other people haven't found. But when I do, then I make some money. So let me tell you what happened. Okay. And I'm not sure some of you might be young and you were kids you know, when he was president first. But something that he used to do he would send tweets. In those days, it was called tweets and on Twitter. Now it's X, but um, about about anger at China. Can you remember that? Okay, he hasn't done it so much this term, but his first term, he did a lot of those tweets about anger at China. Okay, so then what I noticed is every time he made one of those tweets about anger at China, the stock market went down. And then a few weeks later, it went back up. Okay, and it wasn't once or twice, it was many times. So then what I did is I did some research to find out what stocks were reacting a lot. And the funny thing is I found one that no one at the time had ever heard of, and now probably all of you know. It was called NVIDIA. Have you heard of NVIDIA? Okay, it was a little nothing company then. Okay, I wish I had bought a whole lot and held it. But what I did is I looked at the data on tweet day, what I call tweet day, the day he hit his tweet and the end of that day, and what the price was for NVIDIA at the time. And then I waited 1 week later and looked at the price again. And I wanted to see whether the stock went back up. Does that make sense? So I did a few things. First thing is if we're thinking about the level of significance, do I need to be 95% certain? Do you think it's good enough to be 90% certain on the stock market? If you're right 90% of the time, do you think that's good? Or do you think you have to be right more often? I don't see y'all jumping in, but hey, if you can make money 90% of the time that you invest and 10% of the time you lose, you've done really well. Just let you know that. To have that kind of accuracy is amazing. So I decided to use a 90% level of significance, I mean a 10% level of significance and 90% confidence level. You don't have to have that same coordination, but in this case, it made sense. Okay, what I did is again, I looked at the data. So on the first one I was able to look at, I looked back and it sold for 106. And then a week later, the stock cost 113. And then the next time he tweeted, 110, and a week later was 124, etc. Okay, this is different than the last example. Okay, the big difference for this example is this data are dependent. because now this is a pair of numbers, 106 and 113. This 113 should not go over in the second column because it has nothing to do with the 110. It has a lot to do with the 106. It's how much from 106 it went up to 113. So it's very important to see that this is dependent data and not independent data because it's paired. We have the pair of 106 and 113. We have the pair of 110 and 124. We have the pair of 115 and 120 because that's what matters. Any questions on this? Okay. This is also an example where I had to live with a small sample size. How come? Why couldn't I get a sample size of over 30? This should be obvious. Okay, no one's telling me. Because 31 times later, his president's over. It's not going to happen anymore. So I needed to make sure I got this done early enough. So it's one of those I have to make the assumption that we have an approximately normal distribution, even because our sample size is too small. Okay, so it's not perfect, but you can't be perfect with the market. Okay, so this is real data, by the way. So we have to assume the distributions are approximately normal. So then we're going to write down H naught. H naught now is going to be mu sub D equals 0. Any guess on what D stands for? Not dependent. Good try, though. It's a good thought, but it's not dependent. It's another thing that starts. The first letter of the word is D. It's not a trick question. So the idea is H naught is they're the same, right? Well, if the same, then if you look at the difference between the two, you're going to get 0. Do you see? 100, right? Does that make sense? At least the difference between the two population means. Okay, mean differences. It's dependent data, so you got to have mean differences. So mu sub D equals 0, and H1 is mu sub D is less than 0, because what I'm hoping for is that the stock goes up, and the difference is 1 week later is tweet day minus 1 week later. The first minus the second is standard. And if 1 week later is bigger, then tweet day minus 1 week later will be negative or less than 0. Any questions on that? Okay. And mu sub D is tweet day minus 1 week later. Okay, that's a population mean stock price of NVIDIA on the day that was tweeted minus the day 1 week later. Okay, so then we got to find the p-value. Okay, any guess on why I can't use this calculator? There's actually two reasons. What's wrong with this? Yeah, so one of them is data, and now let's go back to the calculator menu. And which calculator can I use? What number? Okay, so you think 18. The problem with 18 is that's two independent samples. But these samples are not independent. Yeah, it's going to be number 21. It's two dependent samples with data. Okay, and by the way, statistics is never really enough. You need the data. So that's why I didn't even make a calculator for with statistics because doesn't happen. So now we got to put in the data 1 and the data 2. So let's do that. That's going to take a little typing. Copy tweet day. Paste it in and put commas. And then I'm going to put in the 1 week later. And then remember, we have a mu sub d is less than 0 for our H1. Confidence level, we're going to go 0.90, 90% confidence. Any questions on that? Okay. In the real world, a lot of times what you do is you look at all the different confidence intervals with different levels and see which one works best. But because we only have so much time, I'm going to just do this. And hit calculate. And there we go. We have our test statistic, which is t, because we don't know the population standard deviation, so it's just going to be a t, student's t-test. We have our p-value of 0.018. That's really important. Let's put that in. Okay. What does that tell you? Let me ask you this. What did that tell me to do? When I saw that p-value, which I did, this is real world. What did that tell me? What did I do after seeing that p-value? Any thoughts? It's really important to know how to use statistics. This isn't just about passing a class, it's really using it. And if you can find something like this, it makes a big difference. So any guess on what I did? Once I saw a p-value of 0.018? Okay, I don't hear y'all jumping in, so let me tell you what I did. One thing I knew, I had statistically significant evidence that a week later after a tweet against China, NVIDIA stock would go up. So what I did is I waited until Trump tweeted against China. And then I bought stock. And then 1 week later, I sold it. And then I waited again, waited a week, sold it. And I did that basically until it is politics, but in his 4th year, he stopped doing that. I don't know if you know that, but a little history. But for about a year and a half or so, I did this. And I made about, in terms of my, if you look at my um, percent interest, I guess, or whatever you want to call it, I made about a 5,000% interest. Okay, so it was very successful. Okay, I didn't put in millions because I didn't have millions. Okay, but I made a lot of thousands of dollars. Okay, and again, you can do that too, but you have to like find something that other people haven't found. Any questions on this? Okay, so let me write down the conclusion for our class. There is statistically significant evidence to conclude that the population mean price of NVIDIA is higher 1 week after the tweet than on the day of the tweet. And again, because of that, what that means is that it's a good idea to buy stock on tweet day and then sell it a week later and then wait till the next one and just keep doing it. Does that make sense? Okay. And this is one example. This is my favorite one because I made a lot on this one, but I've made a lot on others too. Whenever I find something like this and I, pop it in and get a low p-value, then it's time to buy stock and time to do investments the right way. Okay, the confidence interval again was about negative 13.4 to negative 2.4. Okay. Probably 2 decimals is better since it's money, negative 13.42, $13.42 versus $2.24. Okay. Okay, I know those are negative, but remember if the stock goes up, then first minus second is negative. So that means the stock tends to go up about $13 between $2 and $13 or so. But in terms of interpreting it with 90% confidence, the population mean price of NVIDIA goes up by between $2.24 and $13.42 from tweet to 1 week later. Okay. And that's enough to make good money. Okay. It's not a huge amount because remember, if you look at the data, the price was a little more than $100 a share. But that means that in 1 week, I make between about 2% and 13% in a week. And it happened multiple times. So that's why you can make a lot of money. If it only happened once, you're going to make decent money once. But if it happens many times, you can make a lot. Any questions on this real example? Okay, and again, if you can get a chance to make good money and find something that people overreact to and then invest, it's always great. Okay. And that's a really good use of statistics, at least for me, because I like making money if I can. Most people don't say you shouldn't do that. Most people agree that, hey, if you can figure it out, go for it. All right, what I want to do next is give you the word. The secret word is differs because this is a hypothesis test for difference between proportions or a hypothesis test for the difference between two means. So it's how much one proportion differs from another or how much one mean differs from another. And if it's a not equal to, then you're going to use that word differ or different. So that's the secret word. Write it down. I don't hide it. Always make sure that it's really clear, written down so that you can do the secret word quiz. And by the way, you should check if you've missed any secret word quizzes, you have to go back and watch that video and take detailed notes, 5 pages at least, and email it to me, or you're going to lose a lot of money. I mean, not money, a lot of points, 5% per missed one. Okay, so what I want to do now that we're done talking about chapter 10, now it's time to talk about the project. Okay, so let's go back. I want to go back to the syllabus. And project 2 must be finished and turned in by December 7th, okay? Don't tell me on December 8th that, oh, I was having trouble, I couldn't do it, so I didn't turn it in. Can I turn it in now? The answer is either completely no, or I'm going to give you so little credit, you're going to be crying. So don't wait until the last minute to turn it in. Do not wait till December 7th, okay, at night. I recommend December 6th. Kind of put in that calendar. Turn it in by December 6th so that you don't have that, internet issue, for example. Especially like if you're in Tahoe, we could have, issues with internet because we have weather. If you're not from Tahoe, trust us. That weather can happen in December. And in fact, I should give you a heads up tomorrow. I may or may not have internet because they're expecting at the passes are expecting over 100-mile-an-hour winds with rain. And who knows? Okay. So question is, what's the last day to submit a draft? So let me go back here. And right here it says, I'll be happy to look at a rough draft of your paper if you can bring it or email it to me at least by Thursday at 8 a.m. and the week before it's due. So that Thursday before it's due, okay, then you need to, but I don't recommend sending me Thursday because if you're the last to submit it and I have a whole lot to read, I might have 200 pages to read and it could take a couple days and you're not going to hear feedback for a long time. Not because I'm lazy, but because if there's a whole lot to do at the last minute, it just takes me time. And I always read them on a first first submitted to me or first sent to me, first read basis. So I think Monday or Tuesday is a better idea. Again, you have a long time between now and then. So, it's not like, you have to wait till the last minute. You shouldn't. You should start now. You should all have partners. Okay. Partners are an absolute requirement. You can pretty much cannot not get a passing grade on the project if you submit it by yourself. Okay. That would be That's a disaster. So do not even think about not having a partner. Three is always recommended. Two is allowed. And that's the idea is try and get three. And then if someone drops out of the class, then at least you have two. Okay, so that's my recommendation. Okay, so let me click on project two. And I want to let you know project two is not project one. Okay, it's really going to focus on different things. So let me go through some of the details of the project two requirements. Okay, so the purpose of project two is to use confidence intervals and hypothesis testing to support or show lack of support for a research project. Okay, there's one thing that's definitely the same there's a few things, but one thing that's definitely the same as project one is you have to identify a client who'll be making decisions based on the results. Okay. Just like project one, this project should be all about the decisions the client will make. And if there's no decision the client would be interested in making, it's not a good project. Okay. It better have use. Okay. The client should be a person. Okay. No fictitious something. It needs to be a person. Okay. You don't have to actually contact the client, but you better have a name. Okay. So it could be, President Trump if you want it, or it could be, I don't know, Governor Newsom, or it could be, um, how about Tracy Thomas, who's our counselor at our college. Does that make sense? Okay. And it's really easy to look up and find the name of whoever is leading something. Okay, that you can go online and ask. Okay. So you're going to decide what you're interested in researching, and then you design your study and collect your data. I want to let you know this is about hypothesis testing and confidence intervals. The order at which you do hypothesis testing, we talked about that today, and we talked about that last week. That should be the order at which your paper is written. So again, the very first thing you do is you decide an H naught and H1. That's going to be a paragraph or two to talk about why your client would be interested in seeing if H1 is true. Does that make sense? Okay. So again, it's not just writing it in symbols. You do want to write it in symbols, but also you have to do a lot of writing. It's a project, it's paper. It's very different than just exercises. Okay. Any questions on that so far? Okay, so you should have a description of the sampling technique that was made. All right. And any technique may be used for the project, but you must explain how the data was collected, and the data must represent a sample and not a census. So just let you know, any technique is fine. So you're allowed to use convenience sampling for this project. Okay, as long as you admit to it, which is fine. You never lose points for admitting that you use convenience for this project. You don't have to use convenience sampling, but that's the easiest. And you don't want to spend most of your time collecting data. The other thing that's different about this project is that it's not a requirement that you have a survey of asking people. You could actually collect data. So, for example, you could look at, let's say you wanted to find out whether it's colder, there's more snow on the, maybe it's colder in maybe Mammoth than it is in Tahoe. Okay, I have no idea if it is or not. Then you can go online and find a bunch of days in Mammoth and a bunch of days in Tahoe. Okay, you're not going to get a census because you can't get every day that's ever happened, but you can definitely get a bunch of days. Does that make sense? Okay. This study must be a comparison study, either with two independent or two dependent variables. Okay. The variables must be quantitative and subtractable. So do not compare the temperature in Tahoe and the number of people who are in Tahoe on that day, because it doesn't make any sense to say, oh, the temperature minus the number of people, because that's not subtractable. Yeah, so could you Google search? Yes. Okay. If you can pretty easily get the census, that means the entire population, then this won't work for the project. Okay, so the population better be very large, so large that you just can't do it, but you can get a sample. Does that make sense? Okay. The sample sizes must be greater than 30. Unlike the last project, now you're supposed to know why the sample sizes must be greater than 30. How come the sample sizes must be greater than 30? Whereas in the last project, you haven't learned that yet. This should be obvious. Okay. So the sample sizes must be greater than 30. Yeah, to be able to use the central limit theorem. And otherwise, the calculator is just completely false. Okay. So again, hopefully you're learning from this class. If you don't have large enough samples, you have worthless studies. Okay. For, main things. Any questions on this so far? Okay, so now here comes the important thing. You must have a list of the key summary statistics and an independent interpretation of each. Okay, key. So let me tell you some key statistics. And this depends. Let me pop in. I think it's a good idea to go and show you Google Sheets because that's required, by the way. Let me get there. Okay. Same. You must use this, by the way. There's a lot of points taken off if you do not show this in your um, in your project itself. You copy and paste, but it's not one var stats. This is a comparison study, so we're going to be using two var stats. Any questions on that? So I'm going to click two var stats. And now you'll notice it says first and second, and you have data for the first and data for the second. So there should be now two sets of data. You may have independent and you may have dependent. And unlike the calculator for the other calculator that we use, instead of like deciding which one to click on, you have to move your eyeball to the right spot. So if you have independent data, you're looking at J and K. If you have dependent data, you're looking at N and O. Okay, so if you had dependent data, for example, then let's say this was stuff, you would copy that and you would paste it right onto your project. Okay, and that has to be submitted. You lose a lot of points if you don't submit that. If you have independent data, then you would copy and paste these guys right onto the project. Okay. The other thing, if you have independent data, then the stats for A and B are more important. So you probably want to copy and paste these guys too. If you have dependent data, this gives you the mean and standard deviation, and it gives you the other kind of important things. For independent, then you're really going to do the individual because they're independent of each other. Any questions on that? Any questions? Okay, so let me go back. Okay, and by the way, you have to use, it's an absolute requirement to use a spreadsheet. And if you saved it for project one, you should still have it. You don't even have to like redo anything. You just go click on it again. And then make sure you click on the second tab to the for the two variable. So now, or was I here? Okay. So you have to have key summary statistics. And I just want to let you know that the mean and standard deviation are important, but you're not going to spend as much time. But there's one more thing that's new for this project that wasn't in the last one, and that is a standard error. So if you remember, and if you can find it, here's standard error if it happens, whoops, standard error if it happens to be independent. And here's a standard error if you happen to have dependent data. Okay? So make sure you use the right one. And the standard error is very important. So pay special attention for the standard error for the difference. Okay, it's a newly learned statistic for this project. Okay, so that's going to be a main part of the project. Okay, other than means, you do not need to go into too much detail about individual sample statistics, just the means, because that's the key thing. And then the standard error is big. Okay, all right. Again, you must copy and paste what you have. Okay, and you must use a spreadsheet-based program that we're using. Okay. Okay, without including comments about the standard error throughout the paper, you can't receive an A on this. You're going to lose at least 10%. So when you talk about hypothesis test, you better refer to the standard error. When you talk about confidence interval, you better refer to the standard error. Okay? And just in case I have a video on it, in case you forgot about it. Okay, now comes really the two main things that you're going to do in this project. And that is, one is confidence interval. So you can do a confidence interval for the difference. You can interpret it. I want you to know, don't just use the template. The template is for like a one sentence way of saying something. Here you can do full paragraphs. Okay. So just let you know for the confidence interval, yeah, you should explain why you chose the confidence level. And what you should do is you should look at confidence intervals for a 90%, a 95%, and a 99% confidence interval. Look at the pros and cons of each of them and discuss them in your project. And then, based on which is best for the client, based on the pros and cons, and should not just be in general, this is for the client's needs. You decide on which interval to use. Okay? Okay, so hypothesis testing, by the way, you decide before you even collect your data for the level of significance. Level of confidence, you decide after. Okay? And by the way, if you use a 5% level of significance, you don't have to use a 95% confidence level. Okay? They don't go hand in hand. Do not say that's why you chose the confidence level or that's why you chose the level of significance because of the other. That's wrong. So I'm telling you the kind of standard things that people make mistakes on, and that's one of them. Okay. So you should explain what the confidence level is. Okay. Okay. You must explain the ramifications of the population mean difference not lying in the interval after the new decisions are made. And by the way, Ramifications is ramifications to your client. Everything should, this entire paper should be to your client and your client's needs. Okay? Does that make sense? Okay. So everything you talk about should be focused on your client's needs and the decisions your client is going to make. Okay. Don't just write that at the end in the conclusion of your paper. It should be throughout the entire paper. Okay. Um, Also, let's say you chose a 95% confidence level because that like worked well. Determine the sample size you would need in order to use a 99% confidence level with the same margin of error as what you got. And there's a little bit of math you're going to have to do. And if you need help, tutors can help you. I can help you, but you got to put that in. Okay. So just let you know, this confidence interval is a main part of the project. Okay. It's not a paragraph. It's usually pages. Okay. Next is hypothesis testing. So you should have a hypothesis test for the difference. And this has to be done in the order at which we do things. So again, you're going to state the null hypothesis and alternative hypothesis. You should state the motivation for the alternative hypothesis. Just let you know, you should state it in both symbols and words. And you should spend a paragraph or two explaining why this is an important hypothesis to your client and why your client cares about it. Okay. So you're going to do things in the order at which I told you have to do things. The next step is the repercussions of a type 1 and type 2 error. That should be before you talk about p-value, for example. Okay, because before you talk about how you conducted your study, this is done before that. Okay, this is done right after deciding what your hypothesis is. And in fact, it should be done before you even collect your data. You should have it written. So this should be like this week, you can write that part out because it's easy. Okay. Okay. So again, the repercussions will drive what you use for the level of significance. Explain your reasoning for that selection of the level of significance based on these repercussions. And this is the repercussions to the client. How is it going to hurt the client to have a type 1 error? How is it going to hurt the client to have a type 2 error? And based on, remember, 95% is if they equally hurt the client. 90% is if the type 2 error hurts more than the type 1. 99% is the type 1 hurts more than the type 2. Okay, then you talk about how you collected the data. Okay? Cite your source if you use a source, but definitely explain it. Okay? What you're not allowed to do is just make up numbers. You actually have to collect data. Okay? You can find it online. Let's say maybe let's say you work in a restaurant and you wanted to find out whether people give a higher percent tip at dinner time than at lunchtime. Then you just look to see what they tipped. Just wait till you had 31 customers at lunch and 31 customers at dinner. And there you go. You got your data. Just write them down as it comes in. Same rule, by the way, as the last one. For legal reasons, you're not allowed to ask children. Okay? You are allowed to ask college students. So if the college student happens to be under 18, you're actually allowed to ask them because their parents signed that off. But otherwise, you are not allowed to ask children. So do not survey a first grade class and a second grade class. You're not allowed to do that. Got it? Because that's against the law without all kinds of writing and signatures and all. We're just not going there. So don't ask children. Got it? Okay. Also, if you're going to be using it, let's say the restaurant idea, and you're working there, make sure you ask your boss if it's okay. Or let's say you wanted to look at the price in Safeway versus the price in Raley's. Make sure you ask the manager, or if you want to survey people about it, ask the manager first if you work there. I don't want anyone losing their job because they did this study. So get permission first. If you're going to survey students, then ask the professor if it's okay to ask, things like that. Okay, so that's important. Okay. All right, well, you've chosen, so once you've gotten your data, then you're going to find the p-value and interpret it, which means that that's quick. That's just popping it into the spreadsheet program. And you look, notice in the spreadsheet program, it said p-value two-tailed, p-value right-tailed, p-value left-tailed. It just gives all three, and you have to decide which one is the one you've got. You look at your H1 and see whether it's got a greater than, or less than, or a not equal to. Okay, if it was a not equal to, it would be a two-tailed. Okay, if it was a greater than, it'd be right-tailed. If it was a less than, it'd be a left-tailed. Okay, so that's really important. And similarly, confidence interval, we've got them, and you can really easily just change this. You can make it 95, and you'll notice as soon as I hit enter, then it automatically changes these numbers. You gotta wait about 1 second. So be slightly patient, and it just changes the numbers. Okay, so you don't have to do anything other than look at it. So I try to make this easy. All right, so let's look at a little more. Okay, so what decisions will be made based on the results of the hypothesis test? Okay, don't just say, hey, there is statistically significant evidence. Okay, you can say that, but then you better write a whole paragraph on what your client's going to do about that. Okay, then after looking at the p-value, is there reason to conduct a new study? If so, explain why and decide on your new sample size. Okay, this should all be about the standard error, by the way. Okay, don't just write what the homework problems look like, or don't just use the language. This is full paragraphs, so don't use a template. You're going to do a full paragraph about this. Okay. Okay, just let you know if the p-value is like, say, let's say the p-value is 0.83, then you say, oh, I'm not even close to 0.05. A new study is not going to help because I was probably wrong in the first place. Okay, might not have been, or probably wrong. If the p-value is, say, let's say 0.004, and you reject the null hypothesis, you say, I rejected it, I'm good. That's what I was hoping to do, so you wouldn't need a new study. Okay, if the p-value, let's say your level of significance is 0.05 and the p-value is 0.06, you say, oh, I'm so close. I still think I might be right, but I wasn't able to show it. Now a new study with a bigger sample size would make sense. Okay. Okay, you should state what assumptions you made when you found your confidence interval and the p-value. Okay, don't get confused between assumptions and conclusions. Those are different. Okay. Make sure throughout your paper, you should talk about why your topic and results are important. Okay. So not just at the conclusion. You could have a conclusion too, or you should, but make sure you talk about how everything is going to be used, every little detail and how it's going to be used. Okay. A little short discussion on further studies to delve deeper into the topic. Okay, I do have some feedback examples. If you click on that, I'll let you do that. Okay, so that is the stuff to do in project 2. Just note timeline, you should already have partners. Hopefully you do. I would say by the end of this week, have your project idea. Post the project idea on the project 2 discussion board. Not project 1, but the project 2 discussion board. And I'll let you know if it'll work or not. Okay, talk about who your client is, what your population is, what your sample is going to be, how you can collect your data. You should state your null and alternative hypotheses. Okay, and then I'll let you know if this is going to work or not. Does that make sense? Okay, so that should, I recommend by, the end of the week, you can do that, work with your partners. And then next week, get your data. Okay, because yeah, we're in week 8. That'll be week 9. And then in the next couple weeks, get it all written, get it all figured out. You can get help on it. Don't have Chat GPT write it for you. I'll know. And I am such a tough grader when Chat GPT or an AI thing writes your paper. Okay. I'm going to be so meticulous on dropping points if I see that you've used it. So be careful. Okay. And I just quietly do it. I'll just give you a really low score without saying anything other than, oh, you missed this little bit, this little piece. So you lost 30%. Um, so don't use AI to write your paper. Got it? That would be, I'm very mean. Okay. So that, and then I would say, kind of at the beginning of week 11, so like 3 weeks from today or 3 weeks from yesterday, send me the draft. That's what I recommend. Then I'll look at your draft. It makes a huge difference. By the way, if I didn't, but if I did a hypothesis test for the difference between the population mean exam score for those who sent me their draft and those who didn't, I mean, not exam score, project one score, there'd be a very big difference. The p-value would be 0.0001, and the level and for the confidence interval would be like probably 15 to 20% difference in terms of the population mean score so it really makes a difference because then I can help you. Okay. You can also have tutors help too. Don't just have AI write it though. Okay. I know how to tell. By the way, right now I'm doing a national pilot on AI for learning and math. So I'm like on the frontiers of it. So don't think I won't notice. I'll just be quiet about it and I'll grade harsh. That's how I do it. So, but I'm here to help you. Yeah, and the tutors are too, especially Corinne. She's our embedded tutor. So that's about it. I think it's 7:33. We're a little over, but not much. But I always try and go within 5 minutes if I can. So I'm going to stop the recording, but I'm always happy to answer questions. So let me do that now.